Kaleido is a startup focused, focused on providing what enterprises need to be adopting blockchain and related technologies. And what's particularly interesting that we've observed coming at this from what does the business network need to succeed rather than, well, we're just about providing blockchain, is that the overall projects tend to tell us that blockchain as part of the overall transformation of a use case using a decentralized approach is somewhere between 5 and 10% of the overall solution. And that's because what these enterprises are trying to do, and that's our focus is on enterprise adoption, is they're trying to change the way that they do business. They're trying to revolutionize a outdated and broken and inefficient process. They're not trying to adopt blockchain. Blockchain is just a way for them to change the business in a way that they couldn't before. It's a catalyst for change. It's a way that large enterprises can start to think about collaborating in a way that they never have done. And the reality is that the tech stack that's needed to build these enterprise projects looks very similar to the tech stack that's been used for every enterprise project for decades. It has to tackle every one of the traditional layers that every enterprise IT projects had to deal with. It's got to have a data layer. It's got to have a transaction layer. It's got to have middleware to integrate everything that's new with everything that's existing. And of course, you're building applications, but the interesting thing is that every layer is different because it's blockchain. Everything is ever so slightly different, even though it isn't the actual blockchain layer. Every piece of the stack is transformed because you've got this beating heart of blockchain at the center of the solution. Your data is probably going to be pinned to the chain in some way. Your transactions are going to need to be drip fed into blocks in a core data structure which is now shared between you and other participants and isn't entirely in your control. The middleware integration is going to have to worry about these strange-looking blockchain transactions that don't look like traditional REST and web service transactions that you've been dealing with and centralized database transactions that you've been dealing with for all this time. And the applications are going to be built using modern and new technologies like tokens, where we're used to dealing with SQL database tables and NoSQL documents. Suddenly tokens are the equivalent concept in the programming model. So everything's different in the project, but all of those layers need to exist. Now, where privacy fits in is at every single layer. Privacy isn't a layer. Privacy is a requirement that exists at every layer of the stack in these projects. And what we've seen with real projects that have made it to production, and I'll talk in some detail about Congo, is that privacy requirements they butt against the goal of using the decentralized technology. What we want is to collaborate. There's a sort of co-opetition going on. We want a bunch of organizations to share enough data to build a different type of solution to they would have done if it was centralized in one party. And they want to transform the whole of their business. In this particular case for Congo, this is about commodity trading finance, about a system that still is massively inefficient, works on emails between people who know each other, combined with UPS trucks and planes flying around the world moving documents about. And it's about making that 100, 1,000 times more efficient than it is today. But it's also about a group of organizations that don't want to share with each other who they're trading with. It's about transactions which need to work end-to-end in a framework that needs to be agreed with everybody. So you've got this tension between you want everyone to be playing by the same rules. Blockchain's great for that. But you don't want anyone to be seeing what you're doing. You want everyone to be able to see when you're issuing a letter of credit what the terms of that letter of credit were, which organisations you're issuing that letter of credit to. If you're doing KYC, as Congo is also doing, you don't want the data that's involved in KYC to be anywhere near the chain, because of course that's all regulated data, it's all data that you need to forget or delete at some point in the future. So that's the reality of every project that's actually really delivered value in the enterprise blockchain space, is it's thought about privacy from day one. So the stack that exists today, before you look at trusted execution environments and zero-knowledge proofs, which are the emerging space, has built a whole technology stack. And this is what organizations are using in production today. They're performing a whole bunch of off-chain, non-blockchain communications through documents and applications that aren't anything to do with the blockchain itself. They're performing private transactions, they're isolating their chains, they're masking their identity, and they're managing probably more data off-chain than they are on-chain. I'm going to talk through some of the specific solutions, and actually this is one that we heard quite a bit about earlier today. One solution, which was particularly prevalent when Kaleido started a couple of years ago. A bunch of us came from an IBM background, and a proliferation of chains was one approach. If we've got two people who want to trade, well, we'll create a blockchain, a ledger of data that's just for the assets that are involved in that chain and just for those participants. We'll permission them in, we'll create a little sub-chain. It might just have two parties in it. It might have two parties in order to. It might have a sub-network inside of it. We'll create that. It'll have a life cycle. It will come into existence. People will join it. It will die. The challenge there that you have is that these can proliferate. You can end up with n to the order n of these in a network, as everybody wants to trade with everybody else, and also people want to start history afresh. They want a transaction history which is going to be short-lived or long-lived, or additional participants join during the transaction. So these can be a governance nightmare. The other challenge that you have is that state doesn't really, in a blockchain scenario, always need to live inside of one set of trading partners. You want things like total conservation of value. You want rules to be clearly being adhered to by all trading partners in the ecosystem, not just a few. So we see the need to be able to transfer and manage state between chains. So in Kaleido, one really obvious example of this is, well, how can I prove that a small subset of people working on a private chain can't collude together to rewrite history? So maybe we can just do something like pinning the state and signatures from all of our nodes up to a more trusted chain, like the mainnet. It's just the start of the sort of state management that's needed when you have this proliferation of chains. The next approach, which has evolved because of the overhead of sort of creating and managing chains and permissioning people in for sort of the whole overhead of a blockchain or a channel, is private transaction managers. The ability to manage state and execution of transactions that are pinned to the chain in some way. There's some proof that goes to the chain, but most of the data, the inputs and the outputs of the execution are all managed off-chain. This is a really great flexible solution. This is what Congo is using in production to manage the rule set, the smart contract logic, in the pieces of transactions that can't be shared with everybody. But there are some challenges with this as well. You still haven't hidden your identity, whether you're involved in that transaction. You're still submitting and ordering the transaction on the chain. And depending on the evolution of the solutions, and there's lots of evolution happening in this space, you may not have proof of the execution and outputs of the transactions. You might just have the input to the transaction being pinned to the chain. So this isn't a perfect solution, but it's practical, it's workable, it's got the overhead that actually allows production adoption of the tech. So actually this is a really popular technology and approach today. And you can combine it with something like a hierarchically deterministic wallet in order to hide your identity of each transaction that you're sending and make it very hard to analyze trading patterns. Obviously you don't have the data, but if you knew the participants involved, you'd still be able to perform a lot of analysis. So things like hierarchically deterministic wallets and other privacy anonymity tactics can be used in combination with private transactions to hide the information. The reality is, a lot of the transfer of data between participants in a business network, a production business networks, just simply happens using traditional messaging technologies off-chain. So what we see is that every business network that forms that's really doing productive value tends to onboard their members not just onto a blockchain network, but onto a rich, real-time application to application messaging system as well. Maybe there's 10 or 100 to 1 off-chain kind of, in blockchain terminology, state channel kind of transitions of state that are happening in addition to what's going on the chain. Sometimes the output of it is that the transaction's agreed completely off-chain, and all that's written to the chain is just a simple hash that it occurred. Now that's a shame in some cases, because we'd really love there to be rich smart contract logic happening on the blockchain. And privacy and anonymity are actually causing a lot of these networks to just write hashes, and we'd love to get past that. You go one layer up the stack, documents. Managing of documents is huge in the production adoption of blockchain tech, because of course you're trying to reinvent the way that a slow changing business process is working. Probably it's working today using lots of emails, documents, GPS, etc. So actually pinning those documents to the chain becomes critical. Sometimes you can use a peer-to-peer file sharing technology like IPFS or Swarm to do that, but the reality is most of this data is regulated for enterprises, and you need to be able to prove who you sent it to. You need to be able to prove that you deleted it, and you need to be able to prove who you sent it to so that they can fulfill their commitments to delete it as well. So we tend to see adoption of things like document stores with end-to-end encryption and transfer being performed as well. And off-chain compute like zero-knowledge proofs is not new either. There have been technologies baking in the wild, getting real production adoption for a long time. Chainlink's a really interesting example. Sounds crazy for someone like me in the enterprise space to be talking about something that's so synonymous with the mainnet, but actually what Chainlink have done is created a fantastic open source integration technology for on-chain logic to request off-chain compute, and to come back with the result and continue the logic, all deterministic, event-driven model. Fantastic. Thought of as an oracle, but really just an integration and orchestration mechanism that's being used. And there's some fantastic standardization going on at the moment. We're proud, Jim Zhang, my colleague and co-founder, our protocol specialist, is actually part of the Hyperledger Avalon project, which is a project that a number of organizations, Intel and Chainlink and Microsoft and others, that have got together to help orchestrate off-chain compute in a standardized way that's protocol agnostic, is technology agnostic, works just as well for zero-knowledge proofs as it does for TEEs, to try and help standardize sort of some of that plumbing infrastructure that we said can be standardized today. There's real work happening, and this came off the back of an Enterprise Ethereum Alliance standard that's, I think, about 9 months old, that described the technology. Now, Intel as a seed, with a number of collaborators have open sourced that into the Hyperledger Foundation. So all of these are limited and have some challenges around how compromised they are between the ideals of blockchain and completely shared state and the requirements that cannot be broken of privacy and anonymity. So zero-knowledge proofs comes along and looks to everybody like a silver bullet. You show the characteristics that it has on paper in terms of the ability to have completely shared visibility and the ability to prove anything that you like at any point and everybody can see it and everyone can participate. It looks like magic. The challenge is at the moment it also feels a little bit like magic, and it's just out of reach for enterprise adoption. It's not quite at the stage that an organization such as the Comgo Alliance could just like flick a switch and say, we're done with private transaction managers, let's just swap in zero knowledge proofs. The confidence and understandability are not quite there for that to be true. But there's progress being made in all of the key places where it needs to be made. So thank you and keep going, because this is what's really going to matter. And it's interesting that I was reflecting on the plane, but I hadn't put performance anywhere on this chart. And for me, it probably is a lot lower down the list than establishing trust in people who don't have the capability or desire to understand the low-level maths, that the technology works. We all trust TLS 1.2 with, probably most people trust it with 256-bit encryption today. Now, that's just because there's just so much understanding of the technology, maybe not enough to understand where the edges are, but it isn't quite as secure as we think it is. But there's trust in it that it means it can just be adopted without 100 or 1,000 questions. The complexity and skill set needed, even with tools like Socrates and these other tools that sort of package stuff up, it's really still a very, very specialist technology to implement. In Kaleido, we've partnered with Credit because we know that it's actually going to take a real specialist to get a project from wanting to use the technology into production right now. It's not something you can do with commodity skills. The proven scenarios are very limited. Very limited. The ones which everybody can just say, yes, that's been done before and I can do it again. I can't just take smart contract logic and turn it into a zero knowledge proof, and that's probably a way away. But that would be fantastic, right? That's the point at which this turns into really being magic. And I do think that standards and interoperability evolving over time is really going to help the space. It's only going to come from real proof points, but it really does help the space as that evolves alongside the technology. So when we actually look at some of the proven scenarios, really the main one that we actually see being there and available is kind of some form of private asset trading, sort of a dark room. You can either take tokens, coins, other digitally represented assets that exist. You can take them into a dark room, or you can manufacture them inside of the dark room. You can trade them and you can take them out of a room. That transfer of ownership, particularly of numerically identifiable values as sort of fungible tokens, ERC20s in the Ethereum world, that's really well understood and proven. There's lots of techniques that are understood and can be used with them. Beyond that, every time you ask a question, you get 10 answers of technologies that are evolving in the space that could help. So the great news is that there's something that it feels like people can adopt. The room for us all to help is to extend the scenarios that people can use kind of off the shelf. And the opportunities to kind of evolve those are, I generally classify them into four spaces. People want to build ecosystems where the rules are established between all players. They want a referee. They want to be able to say, trading always conforms to these guidelines. And they want to be able to see that they're participating in an ecosystem where nobody can cheat. Which means you need to be able to see enough about what everybody else is doing to be able to prove that they can't cheat. And that's what's great about smart contract logic. At the moment, smart contract logic also allows you to see the data and the transitions and all of the data. So if we can get to the point that zero knowledge proofs helps complex state transition logic be enforced consistently as a set of rules of the game, that will be fantastic. That would help real production projects like Comgo replace less perfect systems. Also, the ability to be able to, at any point that you wish to, say, I have some state, I can prove I've got some state, on demand, and I can share some proof about it. That's a fantastic, generally reusable tool that everyone would love to have in their pocket, particularly for data marketplaces and other things like that. And then the final one, which is critically important in digital assets, really turning into something generally applicable in blockchain, is being able to take real world things and associate them with digital representations that are uniquely identified. And it's a really hard problem. It's much harder than just transferring and managing them all at once on the chain. Proving that this one diamond, this one piece of artwork really does relate to a digital asset on chain is really, really tough. And it seems like that's a space where zero knowledge proofs could help as well. So in Kaleido, what we've done to try and aid adoption of these technologies, because they're so exciting for the kinds of customers we work with, is partner. Our primary partnership is with Credit in the space in order to allow when our skills and experience and sort of non-specialists in the zero knowledge proof, but specialists in the overall blockchain space skills are insufficient, we can actually bring somebody in who knows the space extremely well and has proven technology, is working on standardization, has been there since the beginning of the whole space. So that's something that we're really fantastic, we're really proud of doing, and we're really getting fantastic value out of that collaboration. We've also done something else in order to provide that kind of easy button that enterprises need to understand the technology and see if it could be what they need, is try and take a solution that works today off the shelf, one of those gadgets that really is reusable, and bake it down into the Kaleido platform with a simple enough user experience that anybody can use it. And I wanted to end the session today just by actually showing you this in action. To give you the background in the room, which isn't on the slide, but was for the kind of audiences we normally talk to. This is the collaboration with Quorum, the team that is mainly part of JP Morgan, and Ben Diamond, that some of you may know in the room. They created an extension to Zephyr called Anonymous Zephyr, and packaged it up as a way to perform dark route trading using Sigma bullets. And it's interesting in the space because it's an account-based model rather than UTXO model, which is actually quite novel in the space. Makes it a great fit for the Ethereum ecosystem, which is where we're currently particularly focused. And what I'm going to do, because of the tech here, I did a recording of this at lunchtime. I'm going to try and find the window and push play. What we're going to do is we're going to log into Kaleido. And we've already got a blockchain set up. I've got an environment that I've called Darkroom. It's just got a couple of nodes set up in this. You can go onto Kaleido, set up your own network in a couple of minutes. We're running the Quorum protocol with Raft Consensus as a simple demonstration. And I've got two instances of the token ZKP service from Kaleido deployed, owned by different organizations. So we've got organization 1 and organization 2. I'm going to use the smart contract management features of Kaleido to take a compiled contract. In this case, it's an Open Zeppelin implementation of an ERC20 called Simple Token. And I'm going to generate a REST API that allows me to be absolutely sure I'm running exactly those lines of source from GitHub. I'm running those on my chain with sort of verified compilation of the bytecode, but I'm doing it via a trivial REST API that knows all of the interfaces of that smart contract. With a simple button here, I'm just going to click a REST API, which is going to deploy that to the chain, and kind of all of that infrastructure, obviously, as you'd expect, fully managed for you on the platform. But now I've got an ERC20, what I can do is I can create a shielded counterpart to this, which is a separately deployed smart contract which is going to manage encrypted wallets and the rules to transfer from publicly visible, all participant visible ERC20 tokens down into private tokens inside of the darkroom. And I then have to shield each of the accounts that I want to use. Organization 1 is going to have 5 accounts. Organization 2 is going to have 5 accounts. And what this is doing is generating an URGML encrypted wallet inside of the Zephyr contract that's a counterpart to the public wallet that I've got that anybody could see the trading in. So as I go through and I shield all of these final wallets, this is generating a proof off-chain, submitting it on-chain, which establishes a binding between my public Ethereum address and my private, as you can see here, private URGML private key that I'm going to use for the encrypted balances which are inside of that wallet. I can then click back to my first organization. You can see that I've got quite a large number of these tokens. That's the default value you get with Simple Token. And I can take just 500 of them and I can put them inside of the darkroom. Now that was visible. Everybody could see that I had 500 that I took from the outside world to the inside world. But what I can now do is I can trade those inside of the ecosystem. What I've done is I've chosen one of those shielded accounts from organization 2, and you see here, this is the anonymous extensions to Zephyr that were added by the Quorum team. It's mixing in a whole bunch of other addresses, and you can't tell which ones received value and which ones just had their randomness changed. So you can't actually see who directly was involved in the transactions. You can just see that a transaction occurred that involved some of those participants. Then move across to the other organization, and what we'll see is that they've received some private balance. Now I can see this in the same console in Kaleido because I've got both private keys. I'm managing both of these organizations in the same Kaleido login, but of course this would be private. You can only see the balance of your accounts inside of the private darkroom. But as soon as I click withdraw, what's happened is I've gone from having 250 in the darkroom to, if I go to my wallet in the main Ethereum account, you can see 250 have popped back out of that darkroom into my wallet, and it's visible for the whole world to see. So this kind of darkroom trading scenario seems to be from our experience of the space, seems to be the one which is most straightforward to adopt. There are multiple implementations of it. There are public implementations of it. We've talked about lots of those today, Zcash and others, of trading of simple assets. There's simple, easy to just adopt, no setup versions of them that you can use off the shelf like anonymous Zephyr. And then there's whole organizations like Credit that can help you take that kind of asset trading and transfer and layer on additional facilities like pinning, actually proving something about state transitions before they happen, taking something like, I don't know, off-chain documents and proving you're in possession of a document before you transfer. Where we run out of steam in terms of what we can use off the shelf is when you've got more sophisticated logic. And that's where we're looking to see this space evolve and make it easier for people to adopt. But it's fantastically exciting at this point that we've got a technology that really can be used by enterprises, certainly for POCs at this stage. And we're really excited to see the first one of these production networks really take this emerging technology and do what was done for blockchain a couple of years ago and actually turn it into real use cases that are proved in an enterprise setting with large organizations. And we're excited to be part of that journey. So that was all I had to present today. Really happy to take some questions.
So just one question, what is the size of the anonymity set you use in your darkroom?
So it's actually down to the end user. The UI experience sticks 6 random addresses in there, but it doesn't even actually choose those in any particularly meaningful way. What you saw actually is I had 5 owned by one organisation and 5 owned by the other. So in reality, all I had was 2 participants in there. So users are still going to need to understand set theory. They're still going to need to understand, like, how do I choose the right mixers to put into this set? How do I make sure I'm choosing ones which are actively trading in other transactions, that it's not just, you know, me plus a load of random friends that I always bring in that never actually do anything real. Well, it's obviously just me there. That's still needed to be done by the end users. You know, it's interesting with this particular technology. There's no trusted setup, but actually getting enough people into your darkroom and getting enough trading happening in your darkroom, getting enough value inside of it to have an active ecosystem, that's a pretty big setup in its own right. So it's a different type of setup.
If I want to replace Tether with something else that doesn't have all of those problems, how easy is it to swap out the privacy or darkroom tech with something like Aztec or one of the other options?
So that's a great question. Well, I guess the first answer is very easy, because you just come and talk to the credit guys, and they run directly on Kaleido, so that you swap out to credit. Sorry? They do. I think they may charge a fee, but absolutely. So yes.
Actually, most of that is already ready and implemented. When you approach us, what you get is a sort of other than the API key to play with it, you get a demo Jupyter notebook that shows you, now I'm this guy, I issued my tokens, I see them there. Like all of these steps, you have them as a dev available. One thing that I wanted to mention, we also support something called private issuance, which is the ability to issue a token in a private way, completely private way. And that's for all those use cases where it's not about money or coins, it's about digital twins that you don't want to tell other people.
It's also worth pointing out that Zcash style protocols were the input to a particular input to any transaction could correspond to any of the previous outputs on the blockchain, are fundamentally more secure against intersection attacks, and they maximize the size of the anonymity set, and these approaches where you sort of obfuscate which of several transactions could have been the input, they're actually very vulnerable to active attacks in particular. So Ian Myers has a talk, it was on Zcon 1. If you watch his talk, he goes into detail about attacks against that kind of system.
And the other technology you mentioned there was Aztec. Aztec isn't quite plug and play yet, but that's kind of part of the trusted setup approach, is to get that technology to the point that it can be deployed obviously to the mainnet, but that same technology can be deployed to other chains as well. So that's another interesting technology in the space. Okay. Any other questions? Thank you.
Let's thank Peter again. So